In this video, we are going to talk about portfolio diversification. So in a nutshell, having all your money in one asset versus having all your money in multiple assets or spread across multiple assets, there are different implications to that. Having everything in one place, then you have that entire risk in one place. If you spread your investments across multiple assets, then you're spreading your risk as well. So that's what we talk about. That's what we're talking about when we speak of portfolio diversification. By risk reduction through diversification, which is spreading across multiple assets instead of having all your eggs in one basket. In order to then optimize that benefit you get from spreading your investments across multiple assets, it's not as simple as put same amount of money on each asset. If you do that, then you just equally spreading your investment capital. However, if we analyze the relationship between the assets, we can adjust the amount of money we put in each one of them to get the most out of it with the lowest risk possible. In order to do that, we need to look into the expected return of that portfolio of assets and the standard deviation of that portfolio of assets and how it changes according to the assets we have and how much money we have in each asset. In order to do that, we need to then collect some information. Now, remember, the idea is to get the highest return possible with the lowest amount of risk that we can tolerate, or the lowest amount of risk possible within our tolerance level. So things that we need to know or calculate in order to get to that goal, it's the expected returns of these assets in the portfolio. That is the average return. And this is the formula we use and the description of how we get there. But we will actually perform these calculations on a video on an Excel sheet. Since we will work with multiple assets, more than two. If you have one asset, there's no need to do this. If you have two assets, then there's a way to do it. But if you have 3, 4, 5, 6, 7, 8, 25, 30, 40, 50 assets or more, then you want to get a covariance matrix because we need the covariance between the assets in order to get the most return with the lowest risk possible in order to get to that calculation. So another thing we need to know is the covariance matrix. As you see here, we will be working with this on Excel. Now, covariance is a very important number that deals with a relationship between the assets, how they move together or opposite to each other, and at what degree they do so. Once we have those numbers, we can then also calculate the portfolio standard deviation, which is our measurement of risk. And once we have this information, we can go ahead and start comparing and choosing from the options available. Now, there is more than one way to calculate the standard deviation of a portfolio, but the more assets you have in a portfolio, the lengthier, more complex it gets how to calculate that. The approach we're going to use here is using matrix algebra. Again, we will be running through an example in an Excel video on how to use Excel functions to work with the multiples of matrices and make our life a lot easier. Once we get through those, we're going to see a set of portfolios available. And the ultimate goal is to then identify what was going to be called the efficient frontier. This blue line is what we call the efficient frontier, meaning that when you have a set amount of risk, which you have here on the x-axis, and set of returns on the y-axis, the point is that we're trying to get the most returns we can get for the lowest risk possible. Let's first identify the areas on this graph. The blue line is efficient frontier. That's where you want to be. You don't want to be off that line. Now, anything above the line is we call unattainable, unless we add other assets. Anything above the line is unattainable. Anything below the line, you can have a portfolio there, but it's not going to be efficient. It's feasible, you can get one, but it's not efficient. For example, let's compare portfolio A with portfolio B and C. You see, portfolio A is giving you the same level of returns than portfolio B. So the same percentage, let's say 5%. So if portfolio B is giving you 5% and portfolio A is also giving you 5%, portfolio B is superior because it's over here on the left, meaning a lower amount of risk. So if I can get the same 5% for less risk, then I should choose portfolio B and build it that way. Portfolio A, it's possible you can build it, but it's inefficient because it's giving you the same return as portfolio B, but for a higher amount of risk. So that will be irrational to choose A over B. Now, if we're looking at A and C, we have a somewhat of a similar situation, but from a different angle, a different perspective. Portfolio C is giving you, let's say, 10% up here, 10% return for this amount of risk. So portfolio A compared to C, they have the same risk. They both are in the same spot of risk, but C is giving you higher returns. So for this level of risk, you should not choose A, you should choose C because you're getting more returns for the same risk. So to recap, A versus B, here you can get the same returns for less risk. A versus C is more returns for the same risk. Same returns for lower risk, higher returns for same risk. And that's the idea of identifying this blue line of the efficient frontier, because anything below this line, it's inefficient or it's inferior to any portfolio on the blue line. And anything above the blue line is unattainable unless we include other assets in the mix. We will stop the video here and we will do calculations in a different video on Excel sheet to show you how this works.